Okay, so we are back to our second video. In this video, we'll be talking about the minutia extraction process, which is minutia marking and detection. Now, the concept of this algorithm is it uses the crossing number. It first checks the central pixel value in the block, and if it is 1, it then checks how many neighbors it has. If there is just only one single neighbor, it's a ridge ending. If it's 3, it's a ridge bifurcation. The algorithm basically checks for any special case when uppermost or rightmost pixel to the central pixel value has a value of 1. It checks if they have any branch outside the 3 by 3 block. Now this means that if you look in the third picture, you see the central value is 1, but it also has ones on the topmost and its rightmost pixel block also. Now, those may be involved to another block next to it, and that may be a branch of that block, but it's just present in this block. And we don't want that. What we want is perfect ridge ending and ridge bifurcation, and this is an anomaly. So this is one tricky anomaly that we had to get rid of when getting it done. And so we remove duplicate branches. Now duplicate branches would cause more number of minutiae to be detected, and that would be imperfect for our algorithm. So we don't want any duplicate branches. That's why we incorporate this certain special case, which we call is a triple counted branch. Now, following like continuing with the minutia marking and detection phase, we first calculate the inter-ridge width, which is denoted by D, capital D. Now, that's basically the distance between two neighboring ridges. Now, using all the information that we have successfully marked the minutia points. In the picture, you could see the minutia points being marked in the fingerprint image. These points will be used later on to match exactly this point with the exact location to another fingerprint image with exact same points with the exact same location. This is done. This is the most important stage where the minutiae are getting detected, because the whole system is based on the minutiae getting detected properly. So this substage is very important. Now we move on to the third stage of the minutia extractor block, which is called post processing. Now you may have realized that many minutia points may be false. It may have been detected erroneously, and it may be a problem because it will reduce accuracy of the system. But what we have incorporated, and after analyzing a lot of pictures and all, we have found that there are 7 different false minutia points which would get detected in an image. So what we have to do is we have to remove each and every of those different types of false minutia points from the image, so that all we are left with after the stage will be exactly accurate minutia points, so that we could have a good fingerprint recognition done. Now let's talk about the 7 different false minutia points. The first one is basically a straight line with an edge. Now, what the algorithm for that is with the condition that checks is it checks whether distance between a bifurcation and a termination present in the same ridge block is less than d, which is the interridge width. Then we remove both of them. This condition checks for the first minutia point, false minutia point. Now, for the next two false minutia points, the condition is we check if the distance between two bifurcations present in the same ridge block is less than d, which is the interridge width. Then we again remove both of them. This takes care of 3 different minutia points total, which are like false minutia points. Now, the third condition checks for 3 other false minutia points, which is it checks if two terminations present in the same ridge block are within a distance of d, the interridge width, from each other. And additionally, we'll also check if there are no other terminations involved between the two terminations in the same ridge block. Then we remove both of them. So basically, this algorithm takes care of other different 3 false minutia points. Now let's talk about the last false minutia point. The condition for that is if the termination is of a length less than t, which is the interridge width, and if it is also present in a short ridge, then we remove that. So as you can see, like we have like 4 different conditions which takes care for 3 for 7 different false minutia points. And after this post-processing stage, what image that we have is actually the image that is required, the image with all the correct minutia points. There is no false detections, so that we can use it for getting 100% accuracy in our system. Now, continuing with the false minutia points only, you can see after removing the 7 different false minutia points, it significantly has increased. You see so many like yellow and red on on the other slides. Those have been all removed. Now all we are left with is exact minutia points with exact locations, and we know which location where they are, and the error has reduced a lot. It's reduced by significantly. Next, we move on to the alignment stage, which is the first stage in the minutia match block. Now, alignment stage is an extremely important stage when comparing to fingerprint images. This stage basically it helps in representing 2 different images in the same coordinate system, because we have to have the images in the same coordinate system to match them and map them together to find if the minutia points intercorrelate. Now, for that, we calculate the similarity between the minutia points present in the 2 fingerprint images. And the equation we use is stated there. Now, if we find that the similarity is larger than 0.8, then we rotate all the minutia coordinates to a single reference system. Next, we talk about is the match stage. Now, the alignment stage helps us in mapping 2 different fingerprint images on the same coordinate system, but the match stage basically helps us comparing whether these minutia points are the ones exact same and whether they are located at the exact same location. So it matches all the patterns and locations of the minutia points, and it creates a bounding box around each minutia template, so that the minutia points that are getting matched are present in their respective rectangle boxes. Now, the percentages are again calculated among the total number of matched minutia points to the total number of present minutia template. And if the percent is greater than the system threshold, it is declared as a perfect match. For my system, I have set it at 80%. Now, let's talk about the performance of the system. All we have talked about till now was what are the specifications of the system and how the algorithm works and what stages are involved in this fingerprint recognition system. Now let's see the performance. So I had a total combination of 92 fingerprint images. So I compared every fingerprint image with every one of them and see whether it's giving me matches, false matches, or it's giving me a no match correctly. So I had seen like it gave me 86 positive predictions, and other 6 were wrong. So I could safely say that the system right now has an accuracy of 94 to 97%, which is I believe is good, but we have scope of improving it also, which we are going to talk about in a limitation section. Now, if you look at the quality of the input sensor, you will see like we could use a different quality input sensor. I know optical sensors and semiconductor sensors are good, but if we have used a little more advanced sensor, we could have actually improved the system accuracy, because we would have obtained more clearer images with higher contrast and clarity, so that we could actually enhance it much further to an absolutely clear level. And I still believe that there is still scope to improve the overall algorithm with minor tweaks here and there, and we could use another different combinations of algorithm to correctly detect minutia points, which would then significantly improve the overall accuracy. But that's again remain on like working along with the project later on. Um, so the overall conclusion that I could say is the whole system depends on 3 criteria. One is the clarity of the input image, one is the whole minutia extraction process, and one is the exact proper execution of all the stages involved. You can see in the graph that when we have all the steps, we have higher accuracy. When we tweak the algorithm with different steps and without different steps, for example, without histogram equalization, you can see it's reduced. without doing the HBIC optimizations is reduced. The image binarization is a locally adaptive one, and you can see what happens if we fix that threshold value to 80 and 120, where 80 is a little better but 120 is worse. So I have been doing locally adaptive, which would give the absolutely best results. Now that's like, so it depends on these three things, and the graph clearly states what happens when you execute it in proper stages. Next, we look at the references for our project. So I had used 5 different papers as my reference, and it gave me all the knowledge of minutia-based recognition, fingerprint recognition, extraction, and how image enhancement could be done, different techniques for that, and the extraction process for minutia, and all these different things. Um, Next, but not least, I would like to thank our professor, Deputy Oliver Wu, for his extremely good teaching of the subject pattern recognition. The concepts we learn in this course is extremely useful for future industrial applications. There has been a lot of things going on in the field of pattern recognition and image processing, so this is a very good subject for that. He has always provided us with excellent guidance and always encouraged us to take challenging projects. Professor Wu has always supported and helped us with any difficulty we have faced in completing the class project. He's been an outstanding teacher for us. And that would bring us to the end of our presentation. Thank you so much, and have a good evening.